Most confusion in object-oriented programming starts with a quiet assumption that methods somehow exist outside of execution. They don't. A method exists only while the CPU is executing its lines. Before the call, it does not exist. After it finishes, it does not exist. What creates the illusion of persistence is memory that survives between calls. If you don't separate execution from memory, you'll attribute behavior to methods that they cannot possibly have. Only a few things actually exist over time in a running program. Objects exist in memory. Fields exist in memory. Execution contexts do not. Stack frames are created when a call begins and destroyed when it ends. They are temporary workspaces, not storage. If something must survive, it must be written to memory that outlives execution. Every time a method is called, execution starts fresh. Local variables are created, used, and destroyed in that single execution. Nothing carries over to the next call. If you expect a local variable to build up over time, you are relying on something that cannot happen. These bugs do not throw errors. It silently produces incorrect behavior because the mental model is wrong. A method call is a control flow jump. Execution leaves the current location and enters another execution path. Nothing continues running behind it. When the call finishes, execution resumes exactly where it left off, unless a return ended it early. If you don't think in terms of movement, execution order feels mysterious. If you do, it becomes very predictable. These two lines look harmless, but execution order determines which state exists when check flag runs. Swap the order, and you change the program. Nothing about object structure fixes this. Only execution order does. Many bugs blamed on bad design are actually ordering bugs that were never traced. Return is not a suggestion. When it executes, the method ends immediately. The stack frame is destroyed. Any code below that line does not run, ever. Assuming cleanup happens later is a mental shortcut that creates dead code and hidden bugs. This code looks valid. It compiles. It runs, and log never executes. The compiler does not warn you. Only trace and execution reveals the mistake. Dead code is dangerous precisely because it looks alive. Programs do not remember execution. They only remember state. If history matters, it must be written to memory. If it isn't, it never existed as far as a program is concerned. That is why state tracing matters more than method tracing. First, memory is allocated. Then the constructor executes. That's it. A constructor is not a magical lifecycle stage. It is simply the first method that runs against new memory. It is simply the first method to run against new memory. Every future method depends on what happened here. If the constructor writes nothing, the object starts empty. Later methods cannot recover missing state. The bug isn't later. It started here. Initialization errors propagate forward through every call. Most bugs do not live inside individual lines. They live between executions. They appear when the state between calls is not what you assumed. If you only read code structurally, you will miss them. If you trace state across calls, you will see them immediately. This is the loop that defines all behavior: call, execute, mutate, disappear, repeat. Once this replaces your old mental model, code tracing is very simple, and bug identification is also very simple. There is no magic in object-oriented programming. There is memory, and there is execution. Everything else is naming and structure layered on top. If you can trace execution and state, you understand object-oriented programming. You stop assuming, you stop hoping, you trace, you verify. Design becomes about controlling execution paths and state transitions, not about clever structure.